Welcome to Tunze Tech Tips. I want to apologize first off that there's been a big gap in these videos. I went to Germany for 8 or 9 days. I had a business trip over there to go to TUNZE as well as get some factory training on a product. And after that I got sick. So I'm still recovering from a cold. You probably can hear it in my voice, but we have to get on to another product. And so today we're going to cover the Osmolator 3. This was actually what I went for training on. I picked up my new diagnostic terminal and learned how to update firmware and work with it. This is a pretty new product. These came out in November of 2023. There's a lot of misinformation on forums about them, so that's the main thing I wanted to try to clear up. Fundamentally, this works the same as the old Osmolator. We still have an optic sensor, we still have a safety sensor. That's one thing I see discussed a lot. Oh, it doesn't have a safety sensor. It does. It doesn't have a float switch, but it does have a safety sensor. It still has the 10-minute time limit. It still has all the indicator LED functions. We've actually added even more indicators. The main thing that this addressed was that the biggest failure point of the older Osmolator was water damage. People would get them wet, usually unintentionally. The most common issue was getting a power supply tip that you unplugged from the controller. It landed in a puddle or sump. You plugged it in wet. This is completely waterproof. Even the pump connection is waterproof, and the power connection, while it may look open and exposed, you will see here it's made in Japan, and this is a very high-end gold-plated power connector. While it is exposed, it is incredibly corrosion and water resistant. So getting back to the fundamentals of how this operates, same basics as the original Osmolator, the 3155. And I say original even though it's actually the second generation. There was a 3150 before that. So that's why this is called Osmolator 3. But our optic sensor is now even larger. What that does is it's much less prone to errors from bubbles and from debris accumulating on the sensor. It can go a lot longer between cleaning. Above that we have a thermal sensor. So what's in here is a little micro heater and a little micro temperature sensor. And this is probably one of the biggest causes of issues with customers, is that if you submerge it to here and you power it up, you will perpetually have a white flashing initialization light. What initialization means is that this heater is heating up and it's waiting for the temperature sensor to record very consistent readings to indicate that everything's working and it's calibrated. If water's touching it, water's taking away the heat, it'll never calibrate. Now, it will eventually calibrate and start working once the water level drops below that sensor. Everything on this will automatically reset, except for that too low timeout. So, if you have the white flashing light, you need to lower the water level below that point there. Really, this is a substantial upgrade over the old one, and you only have one wire. It's a very neat installation, and the pump is much quieter, but the same basic principles that were part of the old Osmolator that everyone loved are part of this as well. It just is waterproof and a much neater package. So moving on to the other big upgrade, the pump. Pumps have always been a weak spot of automatic top-off systems. They typically have just been repurposing some existing pump on the market, windshield washer pumps, pumps that run recirculating pet food water bowls or pet water bowls. We, for the first time, have a purpose-built pump just for this application. And unlike any other pump on the market, it is a true DC pump. It has a removable impeller. It can handle 20 feet of head pressure. By default, it's set to handle 12, and I'll show you later how that's set. But this pump has a waterproof connector. You can disassemble it for service. It just has 4 T10 screws. So once we get the screws out, we can remove the impeller. And if there was something obstructing it that can be cleared, it would be very unlikely, but you can replace the impeller. We do sell all the bushings and parts that are inside here. So now that we've got our screws out, here's the cover. There's a bearing on the front. There's an O-ring seal. Our impeller, you can get it out with a little pick tool or needle nose, or just throw and stop short. So here's our impeller assembly. You can see it's a very high pressure turbine design inside of the pump. And the tolerances in there are very tight, so that's something to keep in mind if there is debris in your reservoir that could jam it. But this pump can be disassembled, cleaned, serviced, and you should get a very long life out of it. I would fully expect this unit to last 10 years. We are confident enough in this new product that we give a 5-year warranty on it. And the other highlight of this pump is the old pump used a tubing that was difficult to source in the United States. We did always sell it, and we still do, but it was 4mm inside diameter, 7mm outside diameter vinyl tubing, readily available in hardware stores in Europe, just not here. This new tubing is a more common tubing. Now, we do provide a very top-of-the-line German-made polyurethane tubing with ours that comes in a steel blue color. That's our color, but it's fundamentally 6mm hydraulic tubing that's available on Amazon, eBay. You can get it from Grainger. It's an industrial tubing. Unlike airline tubing, which it's very similar to, appearance-wise, this tubing is very rigid. You can still bend it and flex it and get it around corners, but you can't compress it. And that's important so that when it's in the lock fitting, it stays locked in. But this is a more readily available tubing if you ever wanted to get more tubing. Another thing with the pump, because of the waterproof connection, you can't simply splice this cable. And I can't strongly enough discourage people from trying to cut this cable. These waterproof connectors are not easy to install. Inside here are 3 wires because there's a 2-way communication back and forth with the controller. There's a driver inside the controller that drives this pump, and that's another thing that needs to be pointed out. This is different than the high jet pump that we sell as a retrofit for older 3155 and 3152 controllers. On that pump, the driver is inside the pump. It takes a simple 12-volt DC signal and runs the pump. In this case, we have a digital driver signal from the pump, from the controller to the pump, and they communicate back and forth. And that's important because if you need to extend the wire, you have about 12 feet out of the box. But if you needed it even longer, we sell these extensions. They're 3 meters, which is about a little over 9 feet. And you can use up to 2 of them. If you use more than 2, the signal strength's lost, and you'll always get an error code that there's no pump connected or that the pump's jammed or dry. And that's shown as an orange light on the controller. We'll walk through all the diagnostic lights later. But these cables are available, and I apologize for early adopters. We had some production issues early on with the cable because these connectors are not the easiest thing to install. You can order them right now on TUNZE.com, and very soon we hope to have them more readily available. We've mastered assembly of these, and they'll be more widely available very soon. While we're on the pump, there's a couple of concerns I've had customers express I wanted to mention. So the pump is slightly wider diameter, mainly because of this push fitting. We do sell a simple bushing that you can remove this fitting and put on this little bushing. It takes off a little over a 1/2 inch of this, and then it'll fit in a jug. I've never understood the desire to have the water in a carboy or a jug instead of just a bucket. But if that's important to you, you can do it with this. You just need to purchase that bushing. Personally, I would rather have a bucket. The pump's much more accessible. You use the jug or the carboy to fill the bucket. It just makes more sense to me, but everybody has their own way of doing things. As far as another question I get is, well, I want to get every last drop off the bottom of the reservoir. I can't really say I understand that one either, but compared to the old pump, there's a marginal difference between how much water is left behind. The old pump, even though it stood upright, had little legs which were necessary so that it couldn't just suction itself down to the bottom. On this pump, with that turbine style impeller, the water level can get really low and it still has enough suction to draw in that water. From a practical standpoint, I've been using this product for a year now because I got an early beta model, and I haven't had any issues with it, and it always draws the reservoir down to where there's less than a ½ inch of water left in it. I have seen 3D printing people, make a stand for it that supposedly will get it all the way to the bottom. We've purchased those and tested them, and they made no difference. You still get down to where there's just about a ½ inch left. So the pump works really well as is. I've had people ask me if they could put fittings on here. These are BSP threads. There are fittings available, but they're not going to be the common ones you get at the hardware store in the US. You'll need to search online for BSP thread fittings. It's British Standard pipe thread. But this is ½ inch BSP on the front and 3/8 inch BSP on the top. And you could modify it and put different fittings on there, put an elbow, but it really isn't going to make much of a practical difference. And to be honest, if you've got a ½ inch of water left in your reservoir, the odds that that's going to make the difference between whether your system made it another day or not are pretty slim, so I just wouldn't worry about it. So here I want to give you a demo of the different indicator lights. This unit has a RGB LED that can display red, orange, purple, white, blue, and green. And those all have different meanings. That's discussed in the manual, but let's power it up. And so here we have the initialization that I talked about. This thermal sensor is calibrating. It's going to flash for anywhere from 30 seconds to sometimes up to a couple of minutes. It's waiting to get a stable temperature reading. So there you saw it went blue. That's because it detected that there's no water. That's when the pump would come on. But we have no pump connected, so it's going to this purple error light that there's a general error. So to proceed to show the next indicator lights, which are the orange lights, we've got to connect the pump. You can see there's 2 white dots. We need to get these connectors inserted appropriately to where those dots line up, thread it together, and we'll be good to go with the next part. All right, so now we have our pump connected. Since the pump's connected here, it tries to run, but the pump's dry. So now we have this flashing orange light. That's your pump run dry indicator. One thing that's different with this unit is it is going to keep trying to pump water. It actually runs a program to try to purge out trapped air. It pulses the pump. And so if there were some air trapped in the pump, it will eventually work that out. But in this case, we just have it completely dry and out of the water. Okay, so to show the final couple of lights, I set up a small test tank here. Now we have the solid orange light, and that's because I jammed the impeller with a screw, just for the purpose of being able to show you this. Flashing means the pump's running dry. Solid means the impeller is jammed. Of course, normally that's going to be a piece of gravel or something that got in there, maybe some hair. And you just need to take the pump apart and get that out, and things will be back to normal. Okay, so here I want to demo essentially normal day-to-day operation, how this is going to work in your tank. We've got our pump connected, everything's set up. We've got the sensor out of water. Now I am holding that by hand so that I can easily raise and lower it. And I apologize, I'm trying to work a camera and the sensor at the same time. But the blue light indicates that our water level is low, which it indeed is. The pump is now on. While we're on this topic, I wanted to show you that if you have a tank with trim, you can use the clamp vertically. You can also use it horizontally across the trim. Always make sure that hose is not touching the water surface. This is supposed to be a simulation of a typical sump. I also want to point out that the pump is nearly silent. I mean, compared to the old Osmolator pump or any other top-off pump I've experienced, they don't really get quieter than this. So now we're going to submerge the sensor to the proper level where it's in water. You can see the water's right about halfway across that cone. Now we get the green level light. Pump stopped. Now if I keep submerging it, since we've already gone through initialization, once that safety touches the water, we get the red 2 highlight. If I pull it back out, red 2 high resets, optic sensor detects the correct water level, and I just keep very slowly raising it. Now we have the blue, pump starts back up, and this is how it would work in the day-to-day operation, barring any error codes. Now if this pump were to run 10 minutes, we would eventually get another red light flashing red, which is the too low indicator. Here we have our perpetual stuck in initialization mode, and while we're demoing this, that's because that safety sensor is submerged. But you can see the white light flashes slow. That means it's in normal pump operation mode. The pump has about 12 feet of head pressure. To change that to boost mode, what we have to do is cycle the power 3 times within 5 seconds. And now you see it flashes fast. We're in boost mode. Now we'd have 20 feet of head pressure. If I do that 3 more times, I'll be back to the normal mode. Inside the programming interface, it communicates with it optically. So there's a infrared, or there's 2 sensors in there, an infrared receiver and infrared sender. We place it down in there. Now we're getting our readout on the screen. You can see this has firmware 1.04.08. And if we go to our bootloader, we can see that current firmware is 1.4.9. So we need to get to where we can install it. And you can see here it's showing low water because it's not in water. There's no motor connected. So those things are all reading correctly. Okay, so we just reset it. Go to our bootloader. And here you can see after our reboot and restore, now we're on 1.04.09 and everything's working properly. Just what everybody loves, a PowerPoint presentation. I felt it was important to show that Tunze is a very different company. Most of the companies we compete with, they go to a company in Asia, somewhere else in the world, maybe Italy. They buy a component, they maybe have it customized. We actually build our own products. We have a very vertically integrated production facility in Germany. We wind motor coils, we make plastic parts, we design circuit boards. We do everything in-house, step by step. Here you can see our molding facility. This is actually a separate building from the main factory. It's right down the street, but we own several of these molding machines, and we stamp out the parts. Here you can see the lens caps that go over the Osmolator 3 lens. This is the building. All these molds are maintained. Those racks are actually quite deep, and they're on drawers, and you can get to the different molds. The crane lifts them out because they're quite heavy. Here we see the production of high-jet motor coils. This is a Swiss-made winding machine. It winds multiple coils at once. I believe it can do 8. And this is the finished core. You put the bobbin in and it winds the coil. This pump uses a helical multi-pole coil, but all of our pumps, high jet streams, the E-jets, and our skimmer pumps, those coils are actually made in Penzberg, Germany at our facility. Here there's the ultrasonic welding machine assembling the impellers from the various components. It's kind of a neat Easter egg. We worked with a German company to have our wires made in Germany. That way we're sure of the quality. And we had them make it in the German flag. So we have a black, red, and yellow conductor. These are motors just out of the potting process, ready for final assembly. This is how the production of controllers is done. Circuit boards are installed in the lens. They go into this template. From here they move on to get the magnets installed, and from here they'll go on to potting, which is coating everything with polyurethane for waterproofing.